All right, welcome back to part two of sequences and summation notation. So that first part dealt with sequences. We ended that video on with Fibonacci. Hopefully, you got to look at the short video about Fibonacci numbers. Okay, so this next part is partial sums. Okay, so given a sequence. So if you're given a sequence, so we have a list of numbers. So given a sequence like A1, A2, A3, A4, right? Um, then the partial sums are represented uh, using S1, S2, S3, S4, etc. Okay, and I'll tell you what those mean. So, so S1 just means the sum of the first term. Well, that's just going to be, oops, that's just going to be A1. Okay. S2, however, that means the sum of the first two terms. So you're adding the first two terms. So that's going to be A1 plus A2. If they ask you to find S3, then that means you are looking at the sum of the first three terms. And then same thing with S4. That is the sum of the first four terms. And if they ask you for S5, it's the sum of the first five, etc., etc. Okay. All right. So let's take a look at this first example here where we have to find the first four partial sums. So given by an equals 1 over 2n, 2 to the nth. Okay, so what they're asking you to find is S1, S2, the sum of the first two terms, S3, the sum of the first three terms, and S4, the sum of the first four terms. Okay, so you're going to be finding four sums. Okay, so we don't know what the terms are, so we need to work them all out. Okay, so the first four terms, that way we know what we're adding. First four terms. So A1 is going to be 1 over 2. A2 is going to be 1 over 4. A3 is going to be 1 over 8. And A4, the fourth term, will be 1 over 16. Okay. So we're going to have to find each sum. Let's start with S1. S1 is just the first term. Easy. S2 is adding the first two terms. Okay. So we need LCD. And so we get 3 over 4. Okay. S3, you're adding the first three terms. So that's 1 half plus 1 fourth plus 1 eighth. So we need LCD, which is 8. And so we get 7 over 8 here. And we need the fourth, S4. So we're adding all four together. 1 half plus 1 fourth plus 1 eighth plus 1 16th. So we need LCD, which is 16. And when we add these all together, we get 15 over 16. Okay. So that's what they mean when they say find the first four partial sums. They want each one. They don't want just S4. They want S1, S2, S3, and also S4. Unless they say find find the fourth partial sums, then they only want S4. But if they say find the first four partial sums, then they want each one. Okay. Um, One thing to notice here, it's kind of hard to see it here because we have all the work worked out here. But if you take a look at the list of numbers here in the answers, let's go ahead and take a look. So our first answer was 1/2, and then 3 over 4, 7 over 8, and then 15 over 16. Maybe some of you noticed a pattern here. Okay, so this is again A1, A2, A3, A4. So when you plug in 1, if you take a look at the bottom, that one's pretty obvious, I think. When you plug in 1, you get 2. When you plug in 2, you get 4. 3, you get 8. 4, you get 16. Okay, so those are powers of 2. That's 2 to the n. So we notice that here, so far, the sum, it's 2 to the nth for the denominator. And then if we notice here, let's see, when we plug in 1, we get 1. But when we plug in 2, we get 3. When we plug in 3, we get 7. We notice that these are all one less than the denominator, right? So it's 2 to the n, but 1 less. Okay, so even the answers here form a sequence where you can find a formula for its sum. And we're going to take a look at that later on in the next section for certain sums. And this is nice because if we want to find the sum of the first 100 terms, then I don't have to list each term all the way up to the 100th term, and I don't have to do all of this work here. I can just use this simple formula, plug in 100, and this will give me the sum of the first 100 terms. Okay. All right, so go ahead and try this one. Find the first four partial sums. Given by an equals 1 over n minus 1 over n plus 1. Okay. You can list the first four terms if you want to, or you can just do it in the as you're doing your sums. So you can either list them, or you can go straight to the sums. S1, it's going to be 1 over 1 minus 1 over 1 plus 1. Okay, so you can do that. Okay. All right, go ahead and hit the pause button and then come right back. Okay, so this is the sum of just the first term here, and we get 1 minus 1 over 2. Okay, I'm going to just leave it there for now. If I see a pattern, then I'll just stop there. If I don't, then I'll move to the next step, which is doing that actual subtraction. Okay, S2 is going to be the first term, which is 1 minus 1/2 plus the second term, which is going to be 1 over 2 minus 1 over 3. Okay. And then over here, I notice, oh, if I actually add these together, these two will cancel. So I'll end up with 1 minus 1/3. Always try to find patterns. S3 is going to be 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4. I'm using this one to find the third term. Okay, but I got these from over here. Okay, so I noticed that these two will cancel out. And then it happens over here as well. So we end up with 1 minus 1/4. Okay, so based on what we have so far, S1 is 1 minus 1/2. S2 is 1 minus 1/3. S3 is 1 minus 1/4. Based on our results that we're getting here, what do you think S4 will be? 1. Good. 1 minus what? 1/. Good. And what number do you think will go here? When we plug in 1, we get 2. 2, we get 3. 3, we get 4. So when you plug in 4, what do you think we'll get? If you said 5, excellent. So that is actually what we would get. Okay. And so you just noticed what the formula to find the sum is. It's going to be 1 minus 1/. And how does this relate to these numbers over here? We notice that this number in the denominator is always 1 more than this, right? So if it's n, it will be n plus 1. Okay? They're not asking you to find this. They're actually asking you to find this part over here, but we're leading into this, and I'm just trying to get you to notice that there is some pattern in some of these partial sums. And so if you are able to come up with a formula for finding the sum, then we don't have to do all of this work, because what if they asked you to find not the first 4 partial sums, but let's say they asked you to find the sum of the first 100 terms. You don't want to list all 100 terms and add them up. This is how you would do it. Okay, so if you can find a pattern in the sums, then you can find a formula to find the nth partial sum. Okay, let's take a look at summation notation. Okay, so this section is called sequences and summation notation. Summation notation is also known as sigma notation. If you work with spreadsheets like Excel, you'll see this symbol. Okay, so that's the summation notation. That's the sigma notation. Okay, so sigma notation is just a way to write the sum of the first n terms of a sequence. So let's go ahead and write that down. A way to write the sum of the first n terms of a sequence. Okay, so if I have this sequence here, so you have your first term, your second term, your third term, your fourth term, etc., right? Then you can use your sigma notation. and I'll go over what each of the pieces mean. But sigma notation would be this, which means you're going to be taking the sum. I'll go over what AK is. And K equals 1 all the way up to N. I'll go over what all of these mean. But it basically means you are taking the sum of the first N terms. Okay? All right, so let me go over the parts a little more in detail. Okay, so parts of sigma notation. Okay, so let me write it big like this. All right, so when you see this symbol here, the sigma, this means that you will be adding. Okay, so this tells us to add. Okay, that's our summation notation. Okay, and then you have this here. Okay, so this here is just your formula, the AN formula that we've been working with. Formula for finding each term in the sequence. Okay. All right. So if you need to find the first 5 terms, you would have a formula here written out over here. And if you need to find the sum of the first 5 terms, then you would plug in 1 to get the first term, plug in 2 to get the second term, plug in 3 to get the third term, etc. Okay. So that brings us to this part. So I'm going to go ahead and I won't put a 1 there. Oftentimes it starts with 1. I'm going to put an I there because it doesn't have to start with 1. Okay, so here, this tells us which term to start with. Okay, so if it is 1, then that means you're going to find the sum of the first whatever terms, and you start with the first term. If it says if it says k equals 2, then you're going to start with the second term and then add it all the way up. Okay, if this is a 5, then you're going to start with the 5th term. Okay, so this tells us which term we're going to start our sum with. So this is like our lower limit. And then up here, you will have a number, and this one tells us which term to end with. Okay. All right. So if this one says 5 down here, and this one says 9, then that means we're taking the sum of the 5th term, 6th term, 7th term, 8th term, all the way up to the 9th term. So that's what these two numbers mean. This is like our lower limit, and this is our upper limit. Which term do we start with, and when do we stop adding? Okay. All right, so let's take a look at this next example. Find each sum. Okay, suppose that we have this notation. So we know when we see that we need to find the summation of the first term all the way up to the fifth term. And our formula to find each term is k squared. Okay, so that's what that all means. Okay, so we're starting with the first term. So again, we use this. This is how we find each term. Okay. Hold on a second. Can you listen to that upstairs? Because my microphone.
So sorry. I didn't know you would hear it. Sorry.
Okay. Okay, so to find the first term, you would plug in 1 squared. That's going to be our first term. Our second term, we're going to plug in 2. Our third term, we will plug in 3. And our fourth term, we will plug in 4. And our fifth term, we plug in 5. And that's where we stop because it says here start with the first term. So we're going to plug in 1. And here it says 5. So we stop at the fifth term. So this means we're finding the sum of the first term all the way up to the fifth term. And we use this here to find each term. Okay. And so then this is just 1 plus 4 plus 9 plus 16 plus 25. And when we add this all together, we get 55. Okay. All right. So let's take a look at this next one where we don't start with the first term. Okay. So suppose that we have to find the sum starting with the third term all the way up to the fifth term. And here is our formula. Okay. So we're not starting with 1, so we're not going to plug in 1. Again, this is our formula right here to find each term. Okay. So we're not starting with 1. We have to start with 3. So we plug in 3, and then we'll plug in 4, and we'll plug in 5, and we'll stop there because we only have to do the third term all the way up to the fifth term. So the third term is 1 over 3. The fourth term is 1 over 4. And the fifth term is 1 over 5. Okay. All right. And then we add these all together. Looks like 60 is our LCD. Okay, so that's 20, 15, and 12. Okay, and when we add that all up, we get 47 over 60. So that would be the sum of the third term all the way up to the fifth term. Okay, all right. Let's take a look at this one. Why don't you go ahead and try this sum? The sum starting with the fifth term all the way up to the 10th term. And that's how you will, this is what you will use to find each term. Okay, go ahead and hit the pause button and then come back to see if you get the same answer. Okay, so starting with the fifth term, plug in 5, and then 6, and then 7, and then 8, and then 9, and then we stop at 10. Adding these all up, we get 45. Okay, so you should have gotten 45. Okay, try this one. Find the sum starting from 1 to 6, and that's your formula. Let's see if I can trick any of you guys. Go ahead and hit the pause button and then come right back. Okay, because there's no I here, that means every single term in the sequence is 2. The first term, 2. The second term, 2. The third term, 2. Fourth term, 2. The 100th term, 2. Every single term is the same. They're all 2s. So first term, second term, third term, fourth term, fifth term, and the sixth term. And that's going to give you 12. Okay. So don't be scared if there is no variable here. Okay. That just means that all the terms are the same. Okay. All right, and then we just have a few properties that I have to mention here. So, and then we'll wrap it up. Okay. Properties of sums. Okay, so let's let A1, A2, A3, and B1, B2, B3 be sequences. Then for every positive integer, n and real number c, the following hold true. Okay, so here are your properties. Number one, if you're taking the summation of two sequences, right, you can actually take the sums of each individual one. So you can take the sum of this sequence, you can find that one first, and then you can find this one, and then whatever answer you get here, you can add it with whatever answer you get there. So, okay, so if you are taking the summation of two sequences, then you can split them up. Okay. The second one is for subtraction. Let's save ourselves some writing. So let's go ahead and put minus. So if you have the difference of two sequences, then you can split them up and subtract their answers. Okay, do you see what I did there? If you want to rewrite the whole thing, but with a subtraction, you can for number two. I prefer not to write so much. Okay, and then over here, k equals 1 to n. If you're multiplying by some real number, right, times your sequence, you can actually take out that number and then just find the sum of the sequence. Okay. And then whatever answer you get over here, then you can take that and multiply it with C. Okay. So those are your two properties of sums. You really have three because you have one here for subtraction. So you have one for addition, one for subtraction, and then one for multiplication. Okay. All right. That is it for 8.1. So I will see you next time.